Hey everyone, ever come across a matrix problem asking you to evaluate high power like a to the power 99 and wondered if you are expected to multiply matrices 99 times? Definitely not. Today we are solving this classic matrix problem step by step using a neat binomial expansion trick. Our goal is to find the value of B31 minus B21 divided by B32, where B is equals to a to the power 99 minus I. Instead of computing a to the power 99 directly, let me split matrix A into two parts, an identity matrix and strictly lower triangular matrix C. We can split A because A and I commute, allowing us to use the binomial theorem. It means IC is equals to CI. Now let's look at the power of C. C square is uh, 9 only at the 3 1 position and all other entries are 0. So if we calculate C cube, every entry becomes 0. That is C is nilpotent matrix of order 3. So we expand I plus c to the power 99. All terms after c square vanish completely. Now a to the power 99 is equals to identity matrix plus 99 into this C matrix plus 99 into 49 into this C square matrix. Now on adding all the identity C square and C, we will get this matrix which is a to the power 99. Now B is equals to B is equals to a to the power 99 minus I. So if we subtract identity matrix, we will have this B matrix and we can see the entries B21 is 99 into 3 and B32 is 99 into 50 into 9 and B32 is 99 into 3. So putting in this expression B31 minus B21 21 divided by B32 is equals to 50 into 3 minus 1, which is 50 into 3 is 150 minus 1 is 149. So this is our final answer. Thank you.